Hi students, this is Al Drushler again. This objective we will use interval notation to write a set of numbers. So in many cases, most of the time when you're solving inequalities, like x plus 3 is less than 7, you will find that the answer to that is actually a set of numbers, not just one answer versus when you're solving an equation, like x minus 3 equals 7. There is one answer to that problem. So using interval notation is just another way of writing these sets of numbers. So I'm going to start by writing them in set notation. So first, we'll look at set notation. I may include a graph as well, a basic graph. And then we'll also look at how that is written in interval notation. And I think under the set notation, I may also include the graph as well. So let's say your solution set, and in solution sets, we use curly brackets. So the solution is all values of x such that x is greater than a and less than b. Now, the graph of this, as far as the basic graph goes, and we'll just put a and b right here. So notice x is greater than a, but not equal to a, so we use a parentheses for that. So x being greater than a, that's all numbers to the right. Now x less than b, that's all numbers to the left of b. So it is this set of numbers. So for example, if a was 7 and b was 12, it would be any number that's between 7 and 12. So the way to write that in interval notation, it's actually right from the graph. Notice above a, there's a parentheses. So you'll start with a parentheses a, comma, and then b, and you put a parentheses there. So in interval notation, the first number tells you where the interval starts. So here, this is where we start from. So it will be the number that is on the left. So a is to the left of b. So we start at a and we end at b. B, here, the number in this location, tells you where to end. Now, you use a parentheses next to an endpoint if you do not want to include that endpoint. We do not want to include a as a possible answer here. You would use a square bracket if you did want to include that. And we'll do one of those on the next one here. So let's do another one. So again, we're just going to continue to move down here and keep writing these in two different forms. Okay, so solution set, values of x such that x is greater than or equal to a and less than or equal to b. Okay, so we'll do a basic graph here, a to b. Now, but in this case, both a and b can be included in the solution set. You know, an answer for x can be whatever a is, and it can be whatever b is, versus the last time it could not. So interval notation for this is the interval from a to b. Now you put a comma in between. Okay, so that indicates, if you notice in the curly brackets, it's all values of x such that x is greater than or equal to a and less than or equal to b. Now that would be the answer you would get if you were solving the inequality. A shorter way to express that exact same answer is interval notation. The interval from a to b, including a and b. Okay, so we'll look at another example here. So what if you had all values of x such that x is greater than a and less than or equal to b? On a graph, we would have the interval from a to b, but a would not be included, so we use a parentheses. B is included, so we use a bracket, and the answers are found everywhere in between. So in interval notation, it's the exact same way. We start at A and we end at B. Now we need to look at what's included and what's not. A is not included, therefore it's a parentheses. B is included, therefore it gets a square bracket. Let's look at another one. Solution set, all values of x, such that x is greater than or equal to A and less than B. Okay, very similar. X is found between A and B. But as you can see, A is included, B is not included. And we shade everything in between. And the interval notation is written up exactly the same way as the graph is done. So we have the interval from A to B, where A is included and B is not included. All right, let's look at just a few more examples here. Okay, so what if our solution set looked like this? All values of x such that x is greater than A. All right, the graph has A as the endpoint. And we want to show all values that are greater than A, but not including A. Those will be to the right of A. So when you graph, you just put an arrow to the right, to indicate all values of x that are greater than A. All right, now, this interval starts at A. But where does it end? Positive infinity. All right, now, do we include A in our solution? No. Infinity, we don't actually know what that number is, so we will use a parentheses with infinity as well. Okay, let's look at another one. All values of x such that x is greater than or equal to A. All right, it's exactly the same as the previous example. The only difference is we include A as part of the solution interval. And it's written up exactly the same way, except A is included. Now, you never put a square bracket next to an infinity. Okay? And let's just look at a few more here. So let's say we were given this answer, all values of x, such that x is less than B. We'll just use a different letter. We can use any letter here, actually. So let's look at what that would look like. So B would be here. We want all answers that are less than that. Those are answers to the left of B. So we need to put a parentheses at B, and we need to shade all numbers to the left of B. Okay, where does this interval start? The furthest number on the left, that is a solution, negative infinity. Remember, interval notation always goes left to right. Left endpoint, comma, right endpoint. So negative infinity to B. A parentheses always next to an infinity, and B is not included in this interval, so we put a parentheses next to it. And our final interval, all values of x such that x is less than or equal to B. Okay, well, the only difference with this and the previous one is that B is included. So here's B, and we will put a bracket at B, and we will indicate all values of x that are to the left of B. So this interval starts at negative infinity and ends at B, and B is included. Okay, so just to recap, there's two parts that go into determining interval notation. The first is what real number is the starting point of your interval, and that would be the one to the left. And which real number is the end point, the ending point of your interval, and that would be the one on the right. So the two numbers that go in the parentheses or brackets or combination of parentheses and square brackets is first real number is where the interval starts, comma, second real number is where it ends. Now you look at each real number individually. And if that number should be included in the solution set, you put a bracket next to it. If it should not be included or it's an infinity, you put a parentheses next to it. And once again, if you have any questions, please contact me as soon as possible. This is Al Dreschler.